TNCS earthing arrangement. The terra and neutral, the earth and neutral, are combined within the supply authority's cable and then separate when they get into the installation itself. TNCS earthing arrangement. This is how it will look in a single phase domestic dwelling. How will it look in images shown to us for our exams? The left hand side of this drawing shows the supply authority's cable. It has a separate line conductor and a combined protective earth neutral conductor. This combined cable is the one we can see coming to the bottom of our cutout. This concentric cable has a copper earth neutral and an aluminium line conductor and will enter the building normally underground but can come in overhead. This drawing also only shows one of the star connected windings on the supply authority's side as well as the centre tap point to earth. The supply authorities will provide the metering equipment and cutout fuse rated either 100, 80 or 60 amps for a single phase domestic dwelling. In a TNCS earthing arrangement, the supply authorities provide one conductor for both protective earth and neutral. This pen conductor on the supply authority side is staked throughout its run. We call this PME, protective multiple earthing. This PME in the pen conductor is very important, as loss of the neutral on the supply authority side would mean loss of the protective conductor in the installation. PME helps to prevent this happening. The neutral and earth are separate for the installation. This occurs in the cutout. The pen conductor comes in, a separate neutral and separate earthing conductor come out from the same position. The exam likes to say these are connected together via a solid link. The installation shown on the right hand side can be a lot shorter in length than that of the supply authority's cable, comprising of a line, neutral and circuit protective conductor. The neutral and earth are only combined on the supply authority side and not within the installation. The fuse for this circuit will not be 100 amps, considerably less, maybe 20 amps, and housed within the consumer's unit. The maximum external earth fault loop impedance for a TNCS earthing arrangement is 0.35 ohms. TNS earthing arrangement, terra, neutral are separate. The supply authorities provide us with a separate protective earth and a separate neutral conductor into the installation. If this is what it looks like in a single phase domestic dwelling, how will it look in images shown to us for our exams? The left hand side of this drawing shows the supply authority's cable with a separate line conductor, a separate neutral conductor and a separate protective earth conductor coming into our installation. This is the cable we can physically see in the bottom of the cutout. This cable often comes to installations underground but can also come overhead. This drawing also only shows one of the 3 star connected windings on the supply authority's side as well as the centre tap point to earth. The supply authorities will provide the metering equipment and the cutout fuse sized 100, 80 or 60 amps for a single phase installation. The supply authority's protective earth will be either lead or steel. The installation showed on the right hand side could be a lot shorter in length than the supply authority's cable, comprising of a line, a neutral and a CPC conductor within circuit. As with the supply authority side, we have a separate line, neutral and CPC in circuit. The fuse for this circuit will not be 100 amps, but considerably less, maybe 20 amps, and would be located within the distribution board itself. The maximum external earth fault loop impedance for a TNS earthing arrangement is 0.8 ohms. TT earthing arrangements, terra. The left hand side of this drawing shows the supply authority's cable. In this earthing arrangement, the supply authority will only provide you with a line and neutral conductors to a single phase installation. On the supply authority side, this drawing only shows one of the 3 star connected windings as well as the centre tap point to earth. TT earthing arrangements are often given to buildings that are remote, where it would be uneconomical for the supply authority to provide either TNS or TNCS earthing arrangements. The TT supply is likely to be coming into the installation overhead. It is the responsibility of the consumer within the installation to make their own connection to earth. This earth electrode usually comes in the form of an earth stake, but can come in other forms which we will discuss in the classroom. As the impedance between the consumer's earth electrode and the supply authority's connection to earth can be very high, installations must be additionally protected by an RCD in order to clear earth faults. However, as always, overcurrents and short circuits will be dealt with by the fuse housed within the consumer's unit for each individual circuit. The installation wiring will still be the same as previously stated in TNS and TNCS earthing arrangements, with a separate line, neutral and circuit protective conductor. Also, the metering equipment will be the same, as well as the supply authority's cutout fuse being either 100, 80 or 60 amps.